All right. So today we're going to start off talking about law of sines. But before I do law of sines, which I feel like we've talked about before, if I give you information for a side-side angle, only in that situation, we have to evaluate how many triangles exist, which is what we just explored, okay? So, at the top of this paper, do you notice that I wrote to you, only if I gave you side-side angle?
Yes.
Okay. It really honestly does not matter what letters I give to you, but I put in here, for instance, if I gave you little a, little b, and big A. Do you notice how the A's match on either side?
Yeah.
Okay, the letters do not matter. So I could give you C, B, big C. Give me another combination.
C, A, big D.
Good. B, C, big B. All right. And again, all big letters represent angles. Yes? Yes. I was told that was my trigger word the other day. I always say yes. Okay. Here we go. First thing that you guys told me when you explored. If I give you a right triangle that I have this picture for right here, we do not do law of sines. We do SOHCAHTOA, or Pythagorean theorem. So we do not need to do this for a right triangle. So the first thing I have in here, if you look on the left-hand side of your flowchart, it's either acute or it's obtuse. It's not going to be a right, because if it's a right, we know how to deal with that. Okay? So the next possibilities you told me is either you could have an acute angle, okay, and these situations existed, or you had an obtuse angle, this one existed, and this one did not. Okay, so that's what we're going to kind of step through with this flow chart. All right, first thing at the bottom, where it says law of sines, we're going to write this down today. Law of sines, and I believe it was Micah told me we have sine of A is over little a is equal to sine of B is over little b. Letters to me are not important, so could I say sine of C is over little c? Yes, I could, definitely. Okay, now the other thing I want to emphasize, this is my favorite setup for law of sines if I'm looking for an angle because the angles are on the top. If you're looking for a side, sometimes I prefer to flip these ratios and put the side in the top, because that way mathematically we're just getting it down to one step. So if you're looking for an angle, put the angle in the top. If you're looking for a side, put the side in the top. All right, now pause, look. Do you notice law of cosines? I'm not going to fill that out today, but I did write that we only do law of cosines if I give you a side angle side or a side side side. So all the rest of the cases we do law of sines with. So I just wanted to highlight that. And really, again, only if I give you a side side angle, you pause and we're going to go through this flow chart. And we're going to do some examples so you guys know what I mean. But we need to fill out this flow chart first.
Okay, so I have a question. For law of cosines, it's side-side angle, and then the law of, or no, wait. Okay, anyway. For law of cosines, if there's two sides and an angle, there's two sides and an angle in the law of sines.
Yes, but the way they're placed out in the triangle determines side angle side, or side side angle, or angle side angle. So as we look at some pictures, maybe that will help a little bit.
Okay.
But it's how they're laid out in the triangle.
Okay.
So I'm glad you asked that. Okay. All right, here we go. Step 1. You are always going to determine the height, and the height's going to be your evaluating factor. So do you see the formula I put in there for you?
Yes.
Okay, after that, we're going to start comparing. So then you're going to say, is my angle acute or is my angle obtuse? Okay, so here we go. After you find the height, and I can find this picture that you guys already told me, but what you are telling me right here is if your A is smaller than the height, it matches your picture over here. So here, let's start drawing this in. Here's our angle A. And what you are telling me right here is that the long was coming out first, and then here's the height. There's the height right there. If A is smaller than the height, that's little a right there, I cannot bring it back to the very end. So that's a little bit of what this table right here was telling me earlier with the picture. Okay, is if you have it too high, and little a is going to mean if the height's too tall, you can't complete the triangle. Okay, so if A is smaller than the height, no triangle exists. And you just don't do the problem. You say it's not possible. And we don't go on to do law of sines. Okay? Second picture that you told me is if A is equal to the height. So there's our A. And we have the long noodle coming out. There's our height. And the little noodle was the same as the height. And it completes a right triangle. And if we have a right triangle, let's not do the law of sines. What are we going to do to complete this problem? SOHCAHTOA. Pythagorean theorem if you have enough information. So I'm going to put on here, you're going to have one right triangle. And that you are going to stop and do either SOHCAHTOA or you're going to do the Pythagorean theorem. Why do the law of sines? If you already know something, they'll be a little bit quicker. Right? Okay. Third case. This is what you guys were communicating to me, and I had to drag it out of you a little bit. Yep. Okay, so here's what you were telling me. If you calculate this and the A is larger than your height, that's this picture right here because the height is shorter. So this is the case where it can either kick out or it can kick in. And you have two possibilities. Okay? So the first thing that we're going to evaluate is if A is bigger than B. So there's my A. This means your B is smaller, so the smaller is going to come out first. And then here's our height. And then we finish it out with a long A. So if A is bigger than B, then there's only going to be one triangle. And this is the picture you guys told me right here. So this is if the shorter was coming out of this acute angle. This next one's going to be if the longer is coming out of the acute angle. So if we have the longer coming out, this is the case where two triangles exist. All right, so we're going to draw this picture down. Hope they fix the copier soon with this mark. Does anybody else have a mark right there?
No. I don't.
I know, it's pretty awful. Okay, here we go. Longer comes out. And it can, here's the height of it. And you guys told me when you experimented that you either kicked out the shorter end or you kicked in the shorter end. And so if this is going to happen, you have to give me two possibilities. So I'm going to call again A to B1. It's a smaller triangle. And he's going to have the obtuse angle. And then A to B2 is going to be the larger triangle. He's going to have the acute. Okay, but what we talked about especially was that these were the same size. You either kicked it out or kicked it in. So what was true about the two base angles? They were the same. So therefore B1, that's B1 right there, to B2, add to how many degrees? 180. They are supplementary, yes? Okay. This is the biggest case out of all of them on this paper, okay? And I know as soon as I start putting triangles and numbers, it's going to come more clear. I promise. But we got to have this flow chart for us. But this is the biggest one that we're going to set up. Okay. All right. Last two possibilities that we talked about. If you have an obtuse, okay, and if the shorter, if B is smaller, you're going to have a triangle. But if B is larger, you're not going to have that triangle. That's what you guys already told me right there. Okay, so here we go. If A is less than B, here's what the picture looks like. Yeah, I guess so, because that would be a right triangle then. Okay, so little b is going to come out here. We're going to connect all the way. I think I have that picture flipped. I think I have that picture flipped right here. Can you guys draw an arrow up to here? Okay, because if this is angle A, then the side A right here has to be bigger. Okay, so we're going to just write it over here so we're not going to get confused. Okay, so one triangle exists.
Wait, is this for A is greater?
Yep. Because its side is larger. And then the picture down here, this is what you guys told me, is if this guy is larger and A is smaller, then you cannot connect it back. Okay? Now, logistically, this makes sense because, think about it, if A is obtuse as an angle, then his side must be the largest side, proportionally. Let me say that again so you can write it down. If A is obtuse, then A's side must be the largest proportionally for a triangle to exist. If A is obtuse, then the side A must be the largest for the triangle to exist. I'm going to write that on my own paper so some of you do that. If A is obtuse, then side A must be largest. What? If the angle is the biggest, then the side better be the biggest. There's no triangle for this first one, yep. If A is smaller, then it will not exist. No triangle. Okay, here we go. We're going to start to practice. So the main goal of today is, again, we're doing law of signs. That's the main goal. But if we get a situation that's a side-side angle, we need to take a moment and pause before we do law of signs. That's really what we're shooting for. first of all, I put a new vocabulary term, and it says oblique triangle. This is what I'm talking about, is that we only do law of sines if it's a non-right triangle. Because if it is a right triangle, what are you going to do instead? SOHCAHTOA or Pythagorean theorem. Okay, I also put room on here for you to do law of sines again. So let's go ahead and write sine of A is over little a. Sine of B is over little b. Again, letters to me are not important. And I also clued you in that if you're looking for a side, you may want to flip that proportion back over. Okay, so let's talk about number 1. This is when things will start to become a little bit more clear. But I'm going to look at this triangle that I gave to you and look at this information, and this is what Ella was asking earlier. Going by either direction, I see a side first, an angle first, and an angle. Or going the other direction, I see an angle given, and a side. So this is an angle, angle, side, or a side, angle, angle. Do I need to run through that flowchart? No, we're good to go. We can do law of sines. Okay, so we can jump right into the problem. We're going to do law of sines, and we're going to figure this one out. Okay, what I do want to touch base upon is, do you see on the side of the paper where I wrote ABC and ABC? This is going to be a helpful tip for me, so you're going to do this as well when you do your answers. This is just so I can check them a little bit more easily. Okay, so let's first of all fill out all the information it gave to us. Angle A was 46 degrees. C was 63 degrees. Oh wait, if we have 2 angles, can't we figure out what the third one is? Okay, add them together, subtract from 180, go. 71, thank you. Okay, so we got 71 degrees right here. We were given opposite of C, so we have little c is 56 inches down here. Okay, so now we have a choice, and we can either find side A first or side B. It really does not matter. Okay, so why don't we find side A first? Little a, and he's opposite of 46 degrees. So little a over sine of 46 degrees is equal to, the other opposite we were given was the 56 to the 63. So 56 over sine of 63 degrees. Okay, by setting it up this way, we have one algebraic move. How do we, it says a divided by sine of 46. How do we get rid of divided by? Multiply. You can cross multiply, but by getting this up to the top, we're just going to multiply. You can, but there's only one move you have to do instead of 2. Okay, start typing this in. Watch your parentheses. 56 times sine of 46 divided by sine of 63. Watch your parentheses. And I'm seeing like 45.2. Does that sound right? Okay, good. Now, before I move on, I want to make sure I feel good about this. Let's talk about proportions. 63 degrees is bigger. Is the side of 56 inches bigger than our answer? 46 to 45. Smaller angle, smaller side. Bigger angle, bigger side. So proportionally, am I happy with this before I move on? Why am I saying that is, what if we forget to type a parenthesis into our calculator and you have a misplaced answer? You can pause yourself and look at those proportions, right? Okay, let's set up B. Here we go, step 2, B. B is across from 71 degrees. Okay, you can choose either one. I always go with what was given from the original. So let's do 56 again over sine of the 63. Okay, let's go ahead and type it in. 56 times sine of 71, watch that parenthesis, divided by sine of 63. I am expecting 71 is the biggest angle, so I'm expecting a bigger side than both 45 and 56. 9.4. Okay, good. Okay, before we step away, let's look. Smallest angle, smallest side. Biggest angle, biggest side. Medium angle, medium side. Proportionally, I'm happy with the problem before I step away with it. Okay, before I move on to number 2, what questions might we have? Say it again now. Okay, number 2. Number 2. First of all, I did not give you a picture. If you feel like you need to see a picture, draw a picture. But I'm just going to look at the letters. I have little a, little b, and big A. Angle, side, side. Because one of the angles matches one of the sides. No, we flip that. We do not say it that way. Because it only makes a donkey out of you and Will. Okay, here we go. Because this information, if you need to draw it and see it, but what I am picking up is that this angle matches this side. This is a side-side angle without even seeing a picture. Nope. And if it's a side-side angle, we need to run the information through the case of the ambiguous triangle. So go get out your flow chart.
Yeah.
All right, here we go. First thing I need you to do is to figure out the height. Okay. First question, actually, is angle A obtuse or acute? Acute. So write acute right here. So we do need to figure out the height as our very first step. So we are going to do B sine A. So we are going to do 62 times the sine of 43. And I'm expecting somewhere in the 40s. Have you typed this in? Okay. 62 times the sine of 43. The 40 what? I'm getting 42. Can we check that again, please? Okay, 42.3. So now that we have this height, we're going to use our flow chart and we are going to compare. How does A compare to H? How does A compare to H?
So if it's an SSA, we have to find the height?
Yes. Only if it's acute. Okay, how does A compare to H? A is bigger than. Okay, so look at your flow chart. Right here. A is bigger than H. Now you need to tell me if A is bigger than B or if A is less than B. A is bigger than B. So only one triangle exists. Okay, so as we do this, we only need to do one triangle. All right, here we go. I'm going to start to fill out all the information. A is 43 degrees. Little a is 81. Little b is 62. So that clearly shows me that the first one that we need to do is we need to find big B because that's the only proportional that we have access to right now. Okay, so here we go. To find big B, we are going to do sine of B over the 62 is equal to the sine of 43 over the 81 multiplied by 62. Okay, now you are looking for an angle, so you do not type in sine. What do you type in? Sine inverse. Okay, so let me write down what you're typing in. Sine inverse of 62 times sine of 43, watch your parentheses, divided by 81. Proportionally, expect when you type this in, this side is smaller, I want my angle to be less than 43 degrees. Okay, type it in. If it didn't like it, check your parentheses around the 43.
Wait, why did we do sine inverse and regular sine beside it?
Because you're looking for the sine of B. So anytime you try to find an angle, you have to type in sine inverse. But then you're typing in all of this sides. Okay, and I'm getting 31.5.
Yeah, I got
Okay.
35. I got 31.5.
Pause.
I got the same as
Pause.
William.
Look at your parentheses right now. Do you have sine inverse? Parenthesis should say 62 sine of 43 around the 43. Close off the parenthesis. And then divide by 81. So in your calculator, it will probably pop up parentheses right here.
Okay. Wait, did you multiply by 62 also?
I did, right here.
Oh,
Okay. All right, guys, we have two angles. Can we find the third one?
yeah.
Yes, from 180. Okay, if you subtract that from 180, you're going to get 105.5. Okay, and then proportionally, what's the last thing we have left to find? C. Okay, so since I'm finding side C, I'm going to put C on the top. Okay, C is over sine of 105.5. You can choose either of the two ratios, but I always go with the one that was given to you in the very beginning. So I want to choose this one, the 81 over the sine of 43. I know it does. Triple power the front says. Okay, multiply by sine of 105. .14 is it 5 or 4? 4. And we have now solved our triangle. All right. I'm going to pause this. Does anybody need me to come take a look at their calculator? All right. So, here we go. I'm looking again. Look at the letters. I see a side. Do you have a matching letter? Yes. So this is a side angle. You do need to look at the case of the ambiguous triangle just to make sure. So here we go. Is this angle acute or obtuse?
Acute.
Acute. So if it's acute, our first step is we have to figure out the height. So whatever the other letter is, which is now C, times sine of B. So 71 times sine of 75. I'm seeing something in the 60s. Okay, good. Now we are going to compare. How does side B compare to the height? How does 51 compare to 68? Less than. Okay, go to your chart. Doesn't matter that I had listed B. You're going to look. You just said B is less than the height. No triangle should exist. Does not exist. Should we even do this problem? No. No triangle exists. Moving on, number 4. Okay, look at your letters. Side, side, do you have a matching angle? Yes, this is a side-side angle. You must check the case of the ambiguous triangle. Okay, here we go. Is 40 degrees acute or obtuse? Acute. You must first find me the height. So we are going to do A times the sine of C. And I'm seeing something just below 40. $39.9? Okay. All right, next. We need to compare the matching side of C to the height. How does C, 54, compare to the height? It's greater than. Okay, letter is not important. Go look for greater than. C is greater than the height. Right here is what I'm seeing. Pause, look up. Here's what I'm seeing. So since C is bigger than the height, you may either have 1 or 2. So now we are going to do C compared to the other letter. So here we go. We got to compare it out. How does C compare to the letter of A? It is smaller. So look back here. C compares to the other letter is smaller. We have 2. Okay. Make me another set of A, B, C. And I'm going to call this B, B1. I don't know if I want B1 actually. I'm going to erase that. Hey, Angel. Because we have 2 triangles. 2 possibilities. 2 answers. Okay, let's fill out what we know. We know C is 40 degrees. We know little c is 54. And 54. And we know little a is 62. Okay, so proportionally, do you guys see these ones popping out? That the first thing we need to find is A. These are the ones that are going to be supplementary. Okay, so I would like for you to label it as A1 and A2, and right now I want you to write a note that these are supplementary. So as soon as we find A in the calculator, the first A, you are going to subtract from 180 to find the second A. So your calculator will only give you one of them. Okay, so first thing we're going to do is we're going to find A. Here we go. Sine of A is over 62. Sine of 40 is over the 54. Hey, listen, are we trying to find an angle? So what do we need to type into our calculator? Sine inverse. Okay, you're going to multiply up the 62. I'm going to write that down because it's still pretty new. Sine inverse of 62 times the sine of 40. Watch your parenthesis closing out. And divide by 54. 47.6. Good. Okay, check your calculator. Don't just take Trice and my word for it. Okay, now that we have that, this is up to us. Our calculator will not give us a second answer. You are going to subtract from 180. This other one should be obtuse. 132.4. Okay, now that you have two angles, is that enough information to find a third angle? Okay, so these should all add up to 180 degrees. So I'm seeing 92.4 for the first triangle. And 7.6 for the second triangle. Does that sound right? Okay. It looks like we only have one step left. What do we need to find? B. Now here's what I want to highlight. You have to find each of these B's separately. They are different sizes. So you will have to run each of these separately. So here you go. B over, I'm going to do the first triangle, sine of the 92.4. Hey, no. Is equal to, I'm going to go back to the original OAs, 54 over sine of 40. Okay, now, hey, pause, listen, we're running out of time, so I'm going to write these in. I'm going to write in that this comes out to be 83.9. Proportionally biggest angle, biggest side, I'm happy. I'm going to run this all again, except 7.6 is going to be our side right, or our angle right here. And it's going to come out to be very small, of 11.1. Smallest angle, smallest side. Okay, now listen, I'm going to give you a worksheet. It's going to be on law of sines. Pause. Only if it's side-side angle do you need to run the flow chart, yes? Okay.